On May the 7th, 2010, John Wathen and pilot Tom Hutchins flew out over the Gulf of Mexico. Along the way, we saw small boats dragging buoys out to the islands to protect them from the oil sheen that was certainly coming our way. At 9 miles out, we began to smell the oil. At 11 miles out, we saw a visible sheen on top of the water. Heavy streaking was evident at about mile 15. Mile 26, we began to see solid oil on top of the water with a heavy sheen and numerous streaks at mile 34. Mile 87, ground zero. My first view of the site was one of tremendous impact. I'll never forget the scene. These are not small boats. While standing at a dock looking at them, they look like large ships. They're dwarfed in comparison to what I see on the horizon. Nothing but a red mass of floating goo that could have been prevented and should have been prevented. I was horrified when I looked and saw how many boats there were on the horizon that didn't seem to be doing anything at all that was effective. Going around in circles, small boats with booms on the back of them, sent out to gather up oil in what looked like teacups compared to the horizon. We counted 30 boats in the pictures, all floating around while this stuff was headed for shore. Nobody seemed to be able to do anything about it. For the first time in my environmental career, I find myself using the words hopeless. We can't stop this. There's no way to prevent this from hitting our shorelines.
We are sparing no resource.
We're also using every resource available.
We've utilized every technology available.
Take one.
got a couple other things we want to look at too, along the same lines. This is just some burn oil that he's
got is just burn oil and viscosity out of it. So crude oil would have more viscosity. And stick to something like this even more than burn oil would. There's two types of hay in the southeast United States. And one of them's coastal Bermuda, this main common one, this is it, Bermuda grass. The other is the Bahia grass. Now if you simulate wave, you know, this is, I'm only going to do this for just a few seconds, whereas it can stay in the water for hours and hours and hours, maybe days. The hay won't sink, period. I mean, I've been in erosion control 20, 25 years, and it'll just float to the edge and stay on the edge. As far as getting it out of the water, this is, I've grounded all kinds of stuff in the last few days. This right here is about as green and about as simple as it gets. Now this is just in a few minutes. Now pay no attention to what's around the edge. There ain't no bowl up there in the ocean, there ain't no edges, so this stuff's gonna float and mess around, flop around in the waves. Look at this hay right there. Look what's attached to it. Look at that. But if you've got this known all over the southeast, you could have a lot of hay coming to go on barges to go out to blow in the middle of that. Just blow it out there in the wind. It can't screw up. Because it's going to float around and float into the oil. And it'll attach itself to it. That's a lot different than what I've already done. If it makes it to the beach, worst case scenario, it's going to end there at high tide. It's going to be set. And it'll stabilize right there and be in the hay. So you take this beach seaweed equipment that's pretty readily available. It'll run along there and just roll it, pick it up, and go right in. The oil's coming up. If it washes up there without being attached to something, you got it in the sand, you can't get it. In other words, you got a mess.
Louisiana crude oil was poured into the boomed area and left to spread out over the water. Solidifier was then sprayed from the side of the tank onto the crude oil, concentrating the spray on the leading edge of the oil. And after 1 hour, the crude oil has solidified, and here we show the matted material being raised out of the water.